Hello friends, welcome back to Graph Theory Lectures. This is our lecture number 4 in which we are going to cover subgraphs, induced subgraphs and connected graphs. Okay, so let's start with the definition of subgraph. First of all, we have to take a graph. So let G equal to V, E and a map phi be a graph. Then G1 equal to V1, E1 and phi 1 over E1 is said to be a subgraph of graph G, said to be subgraph of G if V1 is subset of V, E1 is subset of E, and any edge in graph G1 having endpoints A and B, then it should have endpoints A and B in G also. That means an edge should have same endpoints in G as well as in G1. Okay, and any edge should have same endpoint in both G1 and G. Okay, so let's see an example of subgraph. So let this be a graph where 1, 2, 3, 4, these are vertices and these are edges E1, E2, E3, E4 and E5. Okay, so subgraphs are basically all the vertices, means single vertices are subgraphs. Okay, like 1, this is a subgraph, this is a subgraph, another is this is a subgraph, this is a subgraph. But if I will make like this one, 1, 2, 4, then this is not a subgraph. Okay, why? Because 1 and 2, 1 and 4 are not sharing edge, means 1 and 4 are sharing edge, but 2 and 4 are not sharing edge here in the graph G. But here in the graph G1, 1 and 2, 2 and 4 are sharing edge. That's why this is not a subgraph of this graph G. Okay, so these are subgraphs. Now we have next topic, induced subgraphs. Okay, so what are induced subgraphs? So those subgraphs which are which the all the vertices have edges, means same edges as in the graph G1. Okay, so let's give me an example. Suppose this is a graph G, like vertices 1, 2, 3, 4. Then a subgraph this is not a induced subgraph. Okay, why? Because 2 and 3 are having edges in graph G, but in graph G1 they are not having any edge. So the induced subgraph are those graphs in which if two vertices are having edges in graph G, then it should have edge in graph G1. Okay, so if I will make an edge here to here, then a subgraph 1, 2, 3. This is an induced subgraph. Okay, why? Because 1 and 2 are sharing edge, 2 and 3 are having edge, and 3 and 1 are having edge in graph G and as well as in graph G1. Okay, so this graph G1 is the induced subgraph of graph G. Okay, yeah. So now we are done with subgraphs, induced subgraphs, and now we are going to see connected graphs. What are connected graphs? So connected graphs are those graphs in which any two vertices AB belongs to G will have a path in between them. Okay, so what is a connected graph? A graph G such that for all AB belongs to G and B does not equal to A, there exists a path between A and B. Okay, so if this is happening that for all A belongs to G, there is a path between A and B, then that graph is called a connected graph. Okay, so let's see an example of connected graph. A, B, C, D, E, and F. Then here we can see that A and F are connected, right, through a path which is A, D, and F. So you can see that any two vertices will contain a path. Okay, suppose I want a path from A to E, then what will be a path? A to D, D to F, and F to E. So this is a path. Okay, so you can pick up any two vertices here, you will find a path. Therefore this graph G is a connected graph. Okay, so that was all about subgraphs, induced subgraphs, and connected graphs. Thanks for watching.